So the mission of this enterprise that I'm going to be talking about is to gather, organize, and make sense of data to empower insight-driven decision-making. So the idea is analysts typically spend 70% of their time wrangling and 30% of their time analyzing, if they're lucky. And we want to really flip that and do a lot of work up front to make it so that the data makes sense and is findable and understandable by the time the analysts get there. So just to, Comcast, we're big, dozens of tenants, millions of messages, tens of petabytes, thousands of cores. And in case you're wondering why data star, it's not like President Star. I think the Americans in the audience will know what that means. Or Roger Maris winning, the home run star. It's a real footnote, which is, all the data that we use in conformance with, PII restrictions and respecting PII. We never see customer data as specific customer data, all that good stuff. Okay, so quickie quiz. Does your job involve integrating data across corporate silos or verticals or whatever? How many people? Okay. Do you spend more time finding and reformatting data than you do analyzing it? Some pretty enthusiastic hand raises there. When you attempt to integrate your data with other teams' data, are you uncertain what it means? And are you worried that if you join it with their data, it'll come out being Franken data, that is monstrous chimeras that are falsely joined? Two hands up there. I asked those questions at another gathering recently, and there were like 60 to 80% of the people, they were actually polling, 60 to 80% of the people in the audience answered yes to those questions. So, does your big data ecosystem go beyond a single Hadoop provider? That's a harder one. Ooh, 0? 1 or 2? Okay. Well, when it does in the future, I have some ideas for you. Okay, so if you answered yes to any of those, data and schema governance will rescue you. So I am going to talk about, so data discovery, data lineage are the core of what I call data governance. So I don't use that word right away because people think it means like HIPAA and Starbucks and making sure that the lawyers, you keep your email no longer than the lawyers want you to. All that is very important, but that is not what I mean by it. Okay, I mean something much more interesting. So these are the questions the schema governance helps with. I want to join my data with yours. What does it mean? Is it safe to join it? What attributes in your data match attributes in my data? And can I change my schema without wrecking the system of others that use my data? And data governance as opposed to schema governance, where can I find data about a topic of interest? How is it structured? Who produced it? Has the data changed in its journey from ingest into the system, say when it was published to Kafka, to when it gets into the data lake downstream, where I'm viewing it? So that's what a consumer might ask. For a producer, they might ask, okay, I'm publishing this data to Kafka. Where does it go in the system? What happens to it on the way? Is it enriched? Where is it stored? Is it stored here? Is it aggregated? So those are the kinds of things data governance can answer. So challenges of heterogeneity, by which I mean you may use Kafka and S3 in AWS, say. That's Kafka instead of Kinesis, in other words. That's an example of a heterogeneous big data platform. If you want to do data governance and lineage in that environment, there are many excellent data governance tools out there. But most of them that I know, in fact, all of them that I know about except for one, are limited in the types that are supported, so they only support a single Hadoop provider. I'm not going to name names, but that seems to be the case. Or they're not open source. And we needed to add a lot of new data types to our system to be able to track lineage end to end. So that was really important to us. So this is the outline I'm going to talk about. First, Apache Avro for schema governance. What is Avro and best practices to make Avro even stronger? Oh, and who has used Avro or feels they are pretty good at Avro? Okay, about half, a little less than half. And then using Apache Atlas, which is our choice for data governance, for a metadata browser and schema registry, and then the extensions you can do to Atlas for a heterogeneous environment. And then just in general, the architecture for the heterogeneous data lineage. So, Avro. I love this logo, and if I were going to get a tattoo, I would use it. I would get a tattoo of Avro. But I'm not a tattoo person, unfortunately. So, since many people know what Avro is, I'll go a little quickly through these. Data serialization system, a JSON-based schema language, a compact serialized format. So if you store it in a data lake, it doesn't take up much room. It has APIs in a bunch of languages like Java, Python, C#, Go. I'm probably forgetting. I know I'm forgetting some. Pretty much and your favorite language has Avro libraries. And its benefits are really it's cross-language support. So if I publish something using the Avro libraries in Java, I can consume it using the Avro libraries in Python, easily. It's simple but expressive. So the types are a bunch of primitive types, which are kind of what you'd expect. Complex types, records, arrays. A map is just a key-value pair. String goes to some type. A union type or a choice. I grew up using choice type, but basically it's a type. It could be either an int or a float, or a null or a string, which will become important later. A fixed byte array, and then an enumerated field. And so, for instance, it could be either Larry or Mo or Curly, but not Shemp, unfortunately. And I don't know if anybody out there knows the Three Stooges, but if you do, you will know what I mean. Okay, so here's a real simple Avro example. Real simple. It's a log event, application log. So you have the logger name. So it has a name, a type, a default value, very important, and a doc string. And then the actual message that got logged, name, type, value, doc string. And notice the type of the message. It's a union type of null and string. And that's the, I gotta admit it, goofy way that Avro has to say this is optional. It works, I just think it's a little goofy. So, here are some best practices that I would like to share. So each schema, what you can do to really make your Avro schemas really helpful is check them for compliance with conventions that you predetermine at compile time, and then after that, review and approve the schemas by at least one human. So there are some things that you can't programmatically test for. My favorite one is if somebody, we really want good doc strings. And for instance, if the field is called event type, people try to get away with saying the type of the event. We don't let that happen. So that's the kind of thing that, yeah, I guess you could check for that one programmatically, but if you get a little more sophisticated than that, you really can't. So that's one of the things that the people are looking for. So doc comments are required to document all attributes. All attributes must have default values, and this is for schema evolution. So if you have a value, an attribute that's required, and then you drop it, you're breaking schema compatibility. But if it's optional and you drop it, it's cool. And then unnecessary complexity is discouraged. So in my life as a data modeler, whenever anybody has a chance to model in a data model that has nesting, they nest like crazy. The ability to nest is just like, it turns on the worst in all of us. So nesting is great, but enough is enough. So we go by the Yagni principle, which I got from one of my colleagues, which is, you ain't gonna need it. Just think about, are you gonna really need this? And you can also add it later, if you really do need it. But don't just throw it in thinking, wow, I can nest this. On update, basically data must always have a schema. So it's flowing through the system. It has a schema when it's published to Kafka. It might get enriched with some other data added. That creates a new schema, which then maybe the data gets republished to Kafka with the new schema, maybe not. Maybe the schema just gets stored. But everywhere in the system, there should be a schema saying what this data means. Sorry. Updates are permitted, but the schema has to be registered. Schemas may be evolved, but non-compatible changes should be kept to a minimum so that you don't break things downstream. And most importantly, we have a philosophy, or one could have a philosophy, of core subschema reuse. So, and that doesn't mean cutting and pasting your schema. Like code reuse, it does not mean cut and paste. It means embedding common things in other schemas. So the common things, for instance, that you might define are an application, customer account, error logs, the geolocation. I mean, how many different ways are there to say latitude and longitude? You'd be surprised. So if everybody just calls it latitude and longitude, we all know what it means. Timestamp, log events, distributed message tracing, network interfaces like MAC addresses. We add things can be added as needed. If something, they don't have to stay around either. They can be deprecated if they turn out to not be as useful as we thought. So, but that's really important, because then when somebody uses the billing ID for a customer's ID, you know that it's the same as the billing ID over here, and it's not some other ID. That's the join, knowing that you're able to join stuff. So, recap of Acro benefits. So to the business, it allows data integration. It really facilitates data integration down the road from the data lakes, say, to answer business questions of the type that you can't answer with just one data set, but spanning multiple data sets. Integrating data is where you really get real business power impact. And the benefits to data and schema governance are standardization, integrity, everything's documented clearly. You can keep track of data lineage, and I'm not going to talk a lot about this, but Avro schemas have clear compatibility criteria. So, okay, that was the schema part. Now, who has used Atlas? Has anybody used Apache Atlas? Okay, keep me honest. So we use Apache Atlas for metadata and lineage, and I'm going to give you tips on how to do this, I think, in an effective way. Basically, this is a top-level architecture that probably everybody has. Common platforms. On top, maybe you have in-house analytics, and then you have user-facing solutions. So the common platforms might be, let me see if I can use this as a pointer. Data might come in here through the stream data collection, which would be Kafka or Kinesis. It could be transformed and perhaps enriched with some extra data added. Distributed compute would enable more processing, perhaps aggregation, and finally it might end up stored in the data lake. You might have a portal so that it's a real nice UI to discover stuff. But in the middle is governance and security, and it's got a yellow halo because that's the part that I'm talking about. And it's really central to the whole architecture. And in our case, we call this process, this platform, Athene, as opposed to Athena, of which there are a lot. But Athena is the Greek goddess of wisdom, justice, and good governance. So we had to choose that name. But I knew, this was before Amazon's Athena arose. But I knew that would not work. So we named it Athene after the owl, Athena's avatar, the owl of wisdom. So Athene Noctua, the little owl, is her companion owl, and so we named it Athene. And so this is a late 5th century BC coin, literally a picture of one, of the owl. It's gorgeous, for one thing. In the late 5th century BC, yikes. And anyways, it says it's from Athens. But that's good, but we didn't want to use that as our logo, so we used our grunge owl as a logo. And I have a BFA on my team who produced this for our logo. Anyway, that's a little bit of a diversion. Okay, so what does data governance address? Things like, where can I find data about a topic of interest, that is data discovery? How has the data changed either from ingest to where I'm looking, if I'm looking this way, or where can I find derivatives of the data that I published over here, so looking that way. And security, can I control who sees my data, in particular with respect to PII and PCI, which we do a little less of. I'm not going to talk about data security, but I couldn't leave it out. I'm not going to talk much about it, but I couldn't leave it out in a talk about governance. So Apache Atlas. We use it for data discovery in Lineage. So it has a browser UI, has REST and Java APIs. You can talk to it through synchronous or asynchronous messaging, so through a REST API or through a Kafka API. It has integrated security through Apache Ranger. That's probably the last thing I'm going to say about security. But the nice thing is you can tag attributes in Atlas and say, this is PII, and then Ranger can enforce that on certain objects in your system. And then we use it, or it could be used, as a schema registry as well as a metadata repository. So what we really like about Atlas is that it's open source and mostly that it is extensible. So in terms of a schema registry, the idea is that it supports best practices Atlas supports best practices for a schema registry. There are Avro schemas corresponding to Kafka topics, or for that matter, no Kafka topics if it's a batch process. It would handle schema evolution and compatibility, Kafka topic sizing parameters, like not only how many partitions and what are the size of the partitions in Kafka, but what sizing parameters like messages per second and size of messages did the user put in the first place that got calculated into that many partitions. And then, of course, an API for the fully expanded Avro schemas for folks who want to do SERDI. This is a la Confluent, the Confluent API. Too many things with C's, I get confused sometimes. And then one of the nice things that Atlas provides is browsable hierarchical schemas. So if you want to browse a schema, if you want to understand what's in a schema, you can see that, which is the fully expanded, Avro schema ready for serialization and deserialization. Or you can provide this. And this piece right here, this is something, if you click on that, it expands and you see actually a pretty printed version of what you just saw. But most people don't want to see the fully expanded version. They want to see this version. So this schema embeds the following subschemas. So the header schema, the application, device, customer, geolocation, and all of those are live. So you can deep dive into schemas and subschemas, but you can really get a sense semantically of what this means. And you don't have to, unless you enjoy reading stack traces, Java stack traces, which I understand some people do. If you're not one of those people, you can really get a much better sense of what a schema is doing, even a pretty complicated one, through this kind of display. Let's see. So talking about data lineage, for any data item in any data store, community data store. So if people want to go off and take data out and do whatever they want with it, fine. But if it's in a data store for the community, one must be able to identify the corresponding schema. This can be things like compressed Avro binary files in long-term object storage, like S3 or Swift. Hive or Parquet tables derived from these files. Data derived from Hive tables. Say a Hive table put on top of an Avro schema, and then something derived from that. Avro serialized JSON data in NoSQL. Any number of kinds of ways you could keep data at rest. And so Atlas can manage all this, and this is the way it visualizes it. You can get this really nice graph visualization. I hope you can. I know you can't read. I'm sure you can't read the words. Hopefully, those words possibly. But the idea here is this is a Kafka topic. You start by publishing to a Kafka topic. This is a NiFi process that stores in a Hive table. This is a process that stores it in S3, a pseudo directory. Here you got something that transforms it, embellishes it, adds further data, republishes it to another Kafka topic. Then it gets stored, say, in another pseudo directory in S3, or possibly published to a Kinesis stream. So anything that you can do with it is rendered here in a very clear way, and you can click down into these things to see, say, what the transform was that was done, that kind of stuff. Okay. So the internal architecture of Atlas that allows this to happen is this. And what I want to stress is metadata is stored in HBase, and they also index it with Solr. Index things you ask it to index it with Solr. But on top of that is the Titan graph layer, and that's what makes rendering those lineage graphs so easily. You can also query them and say, for this node, tell me whatever's upstream of it or downstream of it. Let's see. Actually, I think do Gremlin queries also. So freeform. There's messaging. So as I said, Kafka messaging going in or coming out of Atlas, and also a REST API, and then various apps that you can view things through. And these are the metadata sources that come with Atlas, at least in version 0.7, which is Hive, Scoop, Falcon, and Storm. The new version 0.8, I think, has a few more. But basically, that's not real big, right? But you can add extensions very easily, typedef extensions. You don't have to, unlike that UI change, you don't have to mess around in the code at all. So things that are very interesting are Avro schemas, Kafka topics. They may have a Kafka topic, but it doesn't have all the sizing stuff that we wanted. So you can extend sizing, S3 buckets, S3 pseudo directories, prefixes, Kinesis streams. We may end up needing to put Oracle tables in there. So anything you want to add, you can add. I think that is an amazing feature. So for our schema registry, we added Avro schemas and things supporting classes. We extended the topic type and reciprocal links between topics and schemas, S3 buckets and schemas, and the like. We also have schema evolution stuff. So schema versions, we have lineage links between versions of schemas. And you can see on that that edge, that edge, whether it was a breaking or non-breaking change. That's all stored. So it indicates forward compatibility, backward compatibility, full compatibility, and as we saw, a better handling of JSON-valued attributes. So that better display works for anything that's JSON, not just Avro schemas. So for data lineage, as I said, we have S3 buckets and objects, kinesis, Hive tables. So we have everything linked up. Hive tables are related to Avro schemas are related to whatever data set they're found in. And because the syntax for publishing to Kafka, the Atlas Kafka topic is kind of verbose and kind of idiosyncratic, we wrapped that in a Java library so that other people can just sort of say, I want to tell Atlas that I just created an S3 bucket, and this is its name or something. You can also use Lambda functions when a bucket is created or a prefix is created. The prefix might have things like the Kafka topic name, the Avro schema name, the version. All of that can be used by the Lambda to tell Atlas this thing just got created. So let's see. And then, sizing attributes could also be added after the fact using this approach. So the real take-home here is Atlas at the center ensures end-to-end governance. So this I have not talked about, but we have Avro schema builders and reviewers. A couple of reviewers are in the audience. So data producers produce the schemas using these tools. Then they produce data to, say, Kafka. Whoops, jumped the gun there. Spark job could do data transformation, store it in the data lake. As I said, these Lambda functions can send data to Atlas. Data consumers can look through the portal. They can also look through Atlas's UI. And peeling it back, we have Atlas has a REST API, the Atlas UI itself, the Kafka topic, and that little REST API that is extra as a wrapper. So that you can't get away with anything in this world. So I just wanted to mention this. These are kind of philosophical thoughts to end. This is a Harvard Business Review article about a balanced data strategy. And they say elements of data strategy, and they have these quadrants, and those are always oversimplified, right? So the idea is things that are a defensive strategy includes governance, you're controlling your data management, and you have a single source of truth, right? An offensive strategy is to improve competitive position. It's basically sort of analytic and giving everybody the chance to do whatever they want with the data. Optimize analytics, it's flexible, multiple versions of the truth, right? So my claim is we should have a new vision of big data architecture. So the big data space traditionally leans toward what they call the offensive paradigm. It's flexible, democratic, schema on read, multiple versions of the truth that's really the rule. But as we know, if we've been around a while, that alone creates chaos where you don't know what the heck anything means or where it is. So if we want, I hope I've made the case for governance. Governance is by its nature defensive, but I guess a new governance approach would see a single source of truth for metadata and lineage, but multiple versions of the truth for data. So data could come in, there could be multiple versions of it depending on who wanted to use it, but a single source would tell you where it is and what it means. So that's what I just said. So a little philosophy at the end, at the end of a day. So In summary, using Avro for schema governance. Avro can be the lingua franca for end-to-end metadata, and the best practices of a sort that I've described can make Avro even stronger. And Atlas for data governance is a metadata browser schema registry, and you can make any type def extensions to Atlas really that you want. And I've listed some things here. It can be across ecosystems, so you can use Kafka as well as S3, and everything works together great. So Atlas at the center of a heterogeneous big data environment enables metadata and discovery lineage to work. And I guess that's it. So thank you. And I guess I have plenty of time for questions. Thank you. I'm an old ballroom dancer, so I'd love to curtsy. Okay, so plenty of time for questions if anybody has them. Yes. Basically, as soon as the data enters the system or as soon as the data is changed. Oh, I'm so sorry. When is the metadata entered into Atlas? And the answer is as soon as it gets into the system. So if so it's entered actually before data is published to Kafka. It's already connected with the Kafka topic. If it goes through and gets embellished by a transform, it would then be sent to Atlas through Kafka. If it goes into the data lake, a Lambda function would tell Atlas. So we're trying to really nip all this chaos in the bud. Anybody else? Yes? The question is the Avro schema extensions, the type definitions for Atlas. Are they available to everybody? And we are working on making them and all of our type defs open source with Atlas. I think the status right now is that they're in Jira tickets in the Atlas open source community. So if you want them, you should go there and say, this is great, we want it. But yes, we definitely want to do that because we think it could be useful. Yes? So Spark is not supported out of the box for Lineage. So how do we work with Spark? Spark would be one of those transforms that would, so what the easiest way to do this is it transforms the data and it puts it into S3. S3 knows about it and it sends it through a Lambda function. Or the Spark job itself calls this Java API and tells. So the first way is better because people don't need to know anything about that other code, but sometimes you have to, Yes? NiFi who? Oh, I believe that NiFi is integrated out of the box, is it not? It's not. Then you would have to extend using that. I think what we did there was just manually, because it was a cool example. Sure. Anybody else? Yes? No, not yet. But we know they're there. Yes?
Do you have an enterprise-wide metadata tool? You try to maintain consistency with others?
No. Comcast is a big place. So what I've been talking about is really something you could use in a large, well, you could use it for an entire organization. That has not happened yet. Our goal is to have it be for a big chunk of the organization right now, and then we'll conquer the world later, you know. But there's no reason why I couldn't. It would just be a matter of, so this brings up an issue that that sometimes comes up. You know, the question is, you know, how do you get people to buy into this governance stuff? And because nobody wants to be governed, right? So my answer to that is top-down mandate helps. But also, the most recalcitrant developer who was doing this, who was made to do this, had an experience where the data that was coming through to a topic that he hadn't done this with, he found two attributes that were exactly the same except different camel case in their name. And they had all kinds of trouble. It broke everything because they didn't recognize that they were the same attribute. And he said, if I had Avro, if this had been Avroized, this would not have happened. And so that was his aha moment. And analysts, of course, love this because it makes their life a whole lot easier. So if you get, you know, sort of pressure from them on the developers, but it's developers, it does, you know, for a short time, it makes their life more difficult. But then after that, they see that it makes it a lot easier. Yes?
Do you have any other parallel initiatives to manage things such as business rules, API, signatures, business processes, constructs that you use to
So the question is, do we have management of business processes and APIs? Okay, so what I've described here is data transforms are covered, but yeah, that is a good idea. I'd have to think about how an API would fit in there, but it's a cool idea. Oh, yeah. Yes. It's about breaking changes to schemas. So our conventions make it difficult, not impossible, to break schemas because we encourage people to, not make breaking changes. We alert them if the change is going to be breaking, and we encourage people to use optional attributes or attributes with defaults to help with that. But they certainly can, if they want to, make a breaking change. Do we alert them to that after they've decided? If we say, you know, that's going to break it, and they say, I don't care. At this point, we don't. We let them go ahead and, you know. But we store in Kafka, in Atlas that change is a breaking change. So if down the road there's a problem, at least they'll see, you know, that's what happened. Okay, a lot of people are leaving. Oh, okay. I understand what you're saying. We haven't had a problem. So let's see. The Kafka stuff is there's no problem with that at all. I guess where you might think it might come up is with the Lambda functions, but that works great. And you know, Amazon claims that they'll give you as much as you need for your Lambda functions, right? So anyway, so we haven't had a problem, but you know, yes. Yes. We try to keep that out. We try to make people see the benefit of putting this in Avro. There are some who won't, And we do handle that in the sense that we let them post it to Kafka, and we store it in Atlas as unstructured. But there's not a lot, you can't really do much else with it, you know? We can say that, okay, it came in and it was stored in this S3 bucket, but you can't really do like schema evolution or, so we do what we can with it. We allow it. we grudgingly allow it. Okay, I think people want to get to the drinks, so
Thank you so much.
thanks a lot.